I'll just pick a start. So my name is Victor, and first off, I'm a PhD student studying chemical engineering at Curtin University, Perth, Australia. At the same time, I really like exploring, learning other things, and I find great value in exploring the tech side of things. And in that end, I'm a Microsoft Learn Student Ambassador. Just recently, I was recently promoted to Gold, which has been which is also offering a further platform to learn further and be a part of my community in this side of things. And I find that it really enhances my learning also as a PhD student, being able to combine certain knowledge that I learned from the tech side of things. So if you're considering if you're considering extracurricular things that you want to do, I highly recommend joining the Microsoft Learn Student Ambassador program. It's a fantastic program that will last you throughout your time as a student, and the learnings there are quite invaluable. The topic for today, as titled, would be integrating custom vision with Powerapps for diabetic retinopathy detection. And this is one of the great ways where you can implement AI in the health industry. And so we're going to explore that a bit later. Linked on the title is just some Microsoft Learn paths that, if you want to be a bit more versed in this topic areas, you can look into. So just some prerequisites, and really all of them are available to you as a student. One is an Azure account, and as a student using your EDU email, you have I can't remember the amount of credits. I think it's 100. I'm sure it's $100. I think for 1 year, every year that renews every year, which you can use to explore different services that Azure has to offer, and so you get that for free. Supposing you're not a student, you can get a trial using another email setup, which I think goes for a month if you want to explore things on the short term. There's also the Power App. We're going to use Powerapps, which is a platform, again, under Microsoft, which will allow us to host the custom vision services that we built, and it allows us to interact with it ideally on our phones. So we're going to use Powerapps, and once again, as part of the Office 365 suite for EDU, Powerapps comes included, so you don't have to pay anything extra to get these services that you need. And so just a rough agenda, what we'd be doing, I'd start off with the objectives and introduction, in terms of introducing the context of where we're going to apply our image classification. And so, yes, and then later on, I'll just talk a bit more on how, what is it, roughly just an overview of image classification, how it works, building the custom vision project, and then building a model, and then evaluating how it works. And then we will connect that to Powerapps, and then we'll go through a bit about, generally, if you're, perhaps there's some who may be unfamiliar with Powerapps, we can go through the layout of Powerapps and how to build a basic app, which is what we're going to do. We're not going to build a very well designed one, although that should be an end goal. But just for the purpose of demonstrating functionality, we'll just have a basic one. And we'll link that to the custom visual model we had earlier, and then look at the accuracy as well from the Powerapps side. So that's what we hope to do. And then just a quick summary, and then next steps, because the one we have here is a very simplistic one. It's just to demonstrate that we can do this, but this, as usual, if you want to broaden your scope, if you want to learn further, there's always things to consider there. And then we'll open it for Q&A later as well. So without further ado, with the learning objectives, I've sort of just mentioned that. So the challenge is to be able to have accurate insights from data sets. In this case, we'll work with a data set from the health science side of things in terms of diagnosing the diabetic retinopathy. And we'll use the custom vision service from Azure to create an image classification solution, and then customize the Powerapps and Powerapps has different components, which are your controls, images, logic, and logic is certain formulas which you can implement. They're simpler than coding, similar actually to how you'd implement it on Excel, which we can see how we can do that. And that will be a key takeaway from this session as well. So I think a good place to start is before we look at the custom vision part of it, is what is diabetic retinopathy? And so, well, from the name, retinopathy, with dealing with the retina, it's a medical condition characterized by damage to the eye. And it's a big thing because it's one of the leading causes of blindness in developing countries, and in particular those who have are diabetic, particularly with type 1, type 2 diabetes, are at higher risk, and that's because of the high blood sugar in the blood vessels that also ends up in the eye, in the retina, and the eye blood vessels are very thin. So having that much sugar can cause damage to the blood vessel, which we'll see the effect of that on the eye. It actually has a visual effect for someone who's actually looking into the retina of the eye. And so the difficulty here is so retinal fundus diseases, which is a general umbrella term for all these diseases that affect the retina, lead to irreversible visual impairment without timely diagnosis and appropriate treatment. And so early intervention is key. So we've seen how severe it is because ultimately, if left unchecked, it can lead to blindness. And so this becomes important because if you consider the rural areas, not everyone has. So we look at timely diagnosis. That means you need an ophthalmologist, ophthalmic services, for example, to actually examine. Typically, to examine the eye, there's this device called a fundoscope, which again needs to be operated by a health professional, and so they actually look into the eye and look at the retina, and then they look for certain features, which we'll see in the next slide, and then they can tell, yes, you have you may be you may be diagnosed with DR. I'll call it DR from now on, or your eye is normal. But if it's in a rural area, that means the facilities may not be there, or it may take time to be able to get the diagnosis and even timely referrals. And so this disease becomes more severe with time and when it's left unaddressed. And so this is the context of where we're coming in. And so we don't necessarily, if we can find a way to diagnose DR quickly without, especially in areas where the professional services may not be as available, that would be a big help in terms of detecting the problem and thus seeking intervention quickly. But the question then becomes, what is the difference between a normal retina and a DR-infected retina? This is just an image to show the difference. And with a normal retina, with a bit of a biological background here, is just it's typically your blood vessels, your veins, your arteries, venules, and arterioles are just branching of the veins and arteries into smaller branches. The optic disc, which connects your optic nerve, and then we have the macula and the fovea. We don't really need to know too much detail onto that. Just that's our reference. And then we compare to the DR-infected eye. One of the things we see is hemorrhages, which are bleeding. And if you recall mentioning those who have diabetes being at type 1, type 2 being at higher risk, and that's because the extra content, extra glucose in your high concentration in these very thin blood vessels causes leaking, and that can come across as the hemorrhages, and that is visually seen. The other thing that we also see is fat deposits, again leaking from the blood vessels. You can see that they're called exudates, so the yellow spots, which you see over there. And then there's this cotton wool spots as well, and aneurysms. So there's certain distinct visual features between a normal eye and an infected eye. Another aspect is an abnormally large growth of blood vessels. And this would happen because if your blood vessel is blocked, the body finds a way to create new ones. And because the eye needs energy, the eye needs waste removed, so it creates new ones. So this again becomes an indicator of DR. And so just also to mention, while this growth of blood vessels is actually a good response, the eye is trying to make sure that all the resources are needed, it actually ends up also hampering vision, because if this retina area is filled with blood vessels, then it actually impairs vision. So it ends up having a negative effect. So these are some of the differences we can look at between a normal eye and a DR-infected eye. And later on, we'll see how we can use this in terms of our classification. So that's just the intro into what DR is. And I think it's important because when we get to work with the data set, added knowledge of what we're actually investigating is useful for us to make good judgments later on as well. So we're going to move on to the actual classification, or how image classification works on Azure. And so generally, image classification, let's get this as well. Generally, image classification is a subset of machine learning, and the aspect here is just to generate a model. You have your input data, you use it to generate a model, and then this model can be able to make predictions. And so in our case would be the types of disease. And so typically there are three ways, common ways which you can look at these models. There are regression models, classification models, which is model of interest, and then there's clustering ones. Regression and classification fall under supervised learning, which is a type of machine learning model where the input is actually labeled. And so in that sense, it's guided. And so these ones rely on well-labeled data sets. Unsupervised learning doesn't necessarily need the data to be labeled. And so, for example, clustering is finding similar looking images, for example, and then it classes those together. So it's a form of unsupervised learning in that sense. Our focus is on classification, and so we'll delve a bit more into how classification, an example of how classification works. And so machine learning classification, the example we use here is just of if you consider maybe a florist or someone who studies flowers, and so you can classify flowers. So what we look at is actually the parameters of the flower. So in this case, we have three flower types, and their difference, they have certain physical differences that we can use as parameters. For example, this is being a petal. There's the length of the petal. There's the length of the leaf. There's length of the stem. Things to look at, length of sepals, which are the green things that when the flower's budding. So those are things which that become quantifiable characteristics, and which we can then use when we collect a large enough sample of each of these flowers. We can create a model through various ML classification techniques, and with that model, we can then classify flowers that are not from within the data set. And we should, if the sample is representative enough, large enough, we should be able to have, and of course well trained, we should be able to make an accurate prediction that this flower falls under the category of the setosa. And I think what can be deduced from this is you cannot make and in such a classification you cannot classify you cannot test a flower you cannot get an accurate test for a flower which is not in your sample, representative sample. So perhaps it may appear that it may be a setosa or something, but that's why we look at probabilities as well. So what is the probability that it shows it will be a setosa? So if this is a setosa, it's quite unlikely that you'll have 100% probability showing you that it's a setosa. It's probably maybe 70, 80% being setosa. So and then you have a threshold which says if it's 80%, we can take that as a positive test for setosa. And so the lower your probabilities, as much as it may be higher than the other two, is an indicator that perhaps your sample may not be fully representative of the flower type, so your test may not fall very well within the current data set that you have of flowers. So that's just a rough way of how we look at classification, general classification. And just to narrow down, we have image classification, which is what we're going to look at. It's the same idea. Again, we have the same parameters that we look at. If you have images, say, of fruits, the key thing with images is pixels. So what we look at is your pixels, and each pixel contains, if you're working with RGB, for example, there's a red, green, and blue parameter which define your output color. And so with that, we can be able to, for example, bananas would have a distinct RGB profile compared to, again, what type of bananas. Again, you're looking at a particular type of apple, particular type of orange. They have distinct RGB patterns. And then we can once again have an image classification model that can then be able to, well trained with a representative sample, be able to get an accurate prediction of a test image of either banana, apple, or orange. So that is image classification from an overview perspective. And so the uses of image classification, our focus is, before I get to actually how we are using it, in other areas that it can be used is in product identification. And the key here is because it's a visual search. So anything that typically a person would use visual inspection to do, it's a good chance it can be not so much replaced, but at least complemented with an image classification model. So product investigation for identification, for searching for specific products online, disaster investigation, and this can be a preemptive way of doing it. For example, if it's a particular city or landscape, you can classify bridges, and so you can look at different bridges, collected for a data set to train a model, and so you can identify bridge areas, and then perhaps you can mark it for emergency preparation and investigation. So it can be used preemptively, and you can quickly scope a large area through using an image classification technique to be able to detect bridges in the area. And that's one aspect. And the key one for us, which we're looking at, is medical diagnosis. And this is becoming it's a really growing field. In fact, what we're going to attempt today is based on this paper. There's a DOI. Perhaps I should put a link on it. It's a 2021 paper published in Nature, and it's about detection of fundus diseases using deep neural networks. So the data set you're going to use is actually based from them. And we're looking at diabetic retinopathy, but there's other diseases that fall under this similar category, and so they investigated them all. And so it's very relevant at this time. Same, and in a similar manner, so X-rays and MRI, they all require to be assessed visually. So when you have an MRI done, there's a radiographer. I'm not sure of the term, but who actually assesses your MRI and then can tell, oh, this is an indication that maybe there's a growth here, there's other medical conditions here, and if properly trained and with the right doctors and imaging people, you can be able to work together to have a quicker diagnosis and also more accurate in the cases which teeter between because not everything is very clear in the sense that it's a positive detection. And sometimes doctors also, especially for those in between cases, can say no further treatment is required, but it may actually be something that may require a referral. So that's where image classification can come in as a complement to helping health experts. So that's just a background on image classification. And so we're going to use Microsoft Azure Cognitive Services, and they fall into 4 branches. So there's vision, speech, language, and knowledge. We are, for our focus, we are going to delve into custom vision. And so under the custom vision side of Azure, typically it's been simplified because what we essentially need to do is, and we access this through the portal, we just need to upload our images. And because this is supervised learning, we need to we need to indicate what type of, we need to give it a proper label. And so in our case, so in this case, we need to label this correctly, so being Lyme. And so again, we'll add another set of images, which maybe indicate for a negative test of Lyme so that we can have a reference. So generally, we do this from the custom vision portal, which we'll look at shortly. After uploading the images, we would then proceed to training. So uploading and properly labeling the images, we would then proceed to training it. And so training is an iterative process, and the custom vision model is rather simplified because we do not have to work with the underlying parameters for machine learning. So at this point, we just train, and all we specify is the time. So you can either go for a quick train or a advanced train, which we just specify the time. We don't touch the parameters, but we do. Later on, we'll see that we do select certain models which are more suitable for image classification. And so once we train, we get these metrics. So and each train corresponds to an iteration. So if you train it once, that would be iteration 1. You make some changes and you train it again, you would have a second iteration. And so we would have these metrics. So we'd have precision, recall rate, and average precision. And so precision generally is what percentage of the class predictions made by the model were correct. And so if we have, say, 100 images of, say, positive DR test, how many of those were, so it means 96.4, say 96 of them were classified correctly. So that's the metric of precision. Recall is a more nuanced one, and it's again just to complement precision. And the definition of recall is more what percentage of class predictions did the model correctly identify. So the example of recall, because it's not as straightforward, I have this little image here to help understand, because we need to understand you can have true positives, which is what was identified by your model. There's false positives, which is what your model identified that as it is true, but it was correctly labeled, correctly identified by the model. And then we have false negatives and true negatives. So the example that I have for the recall, which I caught from Wikipedia, which I thought was nice, is consider computer program for recognizing dogs in a digital photograph. So upon processing a picture which contains 10 cats and 12 dogs, the program ends up identifying 8 dogs. And so with that information, of the 8 elements identified as dogs, only 5 are actually dogs. So it picked 8 of them as dogs, but in reality, only 5 are actually dogs. And those are the true positives, while the other 3 are cats. So they're false positives. 7 dogs were missed, which are false negatives, and 7 cats were correctly excluded, which are true negatives. The program's precision would then be 5/8, which is true positives over the selected elements, while its recall rate would be 5/12, which is true positives over the relevant elements. And so that's just an example of Wikipedia that I had in explaining recall, and I put this little visualization just to help understand the two. But they work together to give you an average precision, which accounts for both precision and recall. And so we'll use these metrics to see whether your model is good enough, or maybe you may need to train a bit more. And by saying train a bit more, before you train again, you need to make a change. So for example, maybe you need to add a bit more images. Maybe you need to add a wider range of images. Maybe you need to have increased your negative have a better reference of your negative test. So there's things you can do to improve the precision, recall, and AP. So that's just an overview of the metrics that we get when you're evaluating our model. And so once you're satisfied with our model, we then we'd publish it, and publishing it avails it for connecting to other services, which in our case would be the Powerapps. And so we'd have a project ID, model name, prediction endpoint, and prediction key for authenticating to be used in other services. So we'll use this later when you're connecting to our Powerapps. And so with that, I will proceed to the section of actually building our custom vision model. I have images of some bits, because some bits take a while. So I'll just show you how I've built the steps I've taken to build mine, and then I'll switch to the actually built model. And so first thing, we would need to go to the Azure Portal, which is portal.azure.com, and we would need to create a custom vision service. So there would be a create a resource button just on the homepage, and once you press that resource button, we have various services, and our service of interest would be computer vision. Sorry, computer vision, not custom vision. We'd have computer vision, and so you'd click on that. And once you do that, you need to have certain settings in place. Because we're doing both training and prediction, we would need to select the both option, and we would need to select a subscription as well, because these services can have costs associated with them. And so typically as a student, I'm sure there's the student subscription. I'm using as a student ambassador, I have access to the Enterprise VS Studio and Visual Studio Enterprise subscription, which allows me a bit more functionality, but generally you can do the same thing on a free one. And so you need to give all your resources are collated in a resource group. So I had one already created as an MLSA demo. And then oh, sorry, I need to select region, which ideally you want to select the region that's closest to you. So I have Australia East, and then name for that, it's DR, with DR standing for Diabetic Retinopathy. So that DR demonstration. The pricing tier, so there's a free option here, which allows you, I think, for 2 transactions per second, which is fine for this purpose of just building a functioning app. I had, again, I think essentially because I had the option, I picked the standard S0 option, which is allows for 10 transactions per second. I think it comes at a cost, I think, but it's a small cost, but you can pick for your case, if you're coming from using your EDU email, you can pick a free option if it suits the current training that you want to do. And so with that, you would then review and then you provision a resource. And once you do that, you'll be notified that it's been created, and you'll have 2 items here. So we have the prediction custom vision type and the training one. So you'll have this created, and to be able to access these, we will then move over to the custom vision website, and then we can access this and create projects from that side. So this is on Azure. We then move on to customvision.ai, and once we're there, we will be told, once you click the resource, there's a resource button you can click on, and you'll see the same items that we created earlier from Azure. You can see them on this side, and so these are what you're going to use later for on our project. And so with that, we need to create a project, and in a similar manner how we did on Azure when creating the custom vision instance. For this project, we just need to give it a name. DR Demo 101 is what I gave it. Again, DR stands for Diabetic Retinopathy, and a brief description of the project. Resource, DR Demonstration S0. I created this from Azure, so I just linked it on this side. Project types. So we have classification and object detection. So object detection is more of when you're looking for an object within an image. So classification here is a focus on the whole image, but if you're precisely looking, your focus is on a particular object area, an area where looking for a particular object within the image, then your best bet would be object detection. However, in our case, because there's many features, if you recall to the first slide I showed on an infected DR positive eye, there's many features to look at, and it's easier. And also at this level we're at exploring this, it's easier just to work with the classification model. And classification types, we have the multi-label and multi-class. And in our case, we are going to we're going to look at we're going to have either a negative label or DR positive label. And so we're going to associate an image with just one label. If you have a case where you want to associate multiple labels to an image, multiple tags to an image, then your bet would be multi-label. But for simplicity and for our current case, we just work with the multi-class. And then we have these domains. And domains, so this is really to help us with sort of a preset thing, because if you're working with if your domain is in food, then the certain parameters have already been run and set, which are more suitable for classifying food data sets. So these are some of the ones you can use. General A2 is actually recommended for if your data set doesn't fit a particular class here, because we are classifying retinas or eyes. I don't think we have an exact fit for that. A2 is recommended because it's faster than A1, and so I just went with that. On the documentation, you can read through, and this is a good habit generally when you're building apps, is you have access to all this knowledge which Microsoft have in the documentation. And so if you're unsure, you just refer, which is what I did. And so I found that general A2 was actually preferred because of better accuracy with faster inference time than A1. And so went ahead and used that. Now, now we get to the actual data set. I got this from Kaggle. And so the paper I showed earlier, this is their data set, and you can see it's DR is, so we have the normal eye, we have DR1, DR2, DR3, and we have other fundus eye diseases, which we are not going to focus on this point. Now, I said that we're looking at negative and positive DR. Actually, and this is why, again, an image classification model may be useful. This positive is general, but the previous person who did this actually just classified between negative and positive, but I felt looking at the data set, we can actually go a bit deeper because positive falls under DR1, DR2, and DR3. And DR1 often is when it's positive, but it's not serious in the sense that they call it non-referable. So you don't need a follow-up appointment when you have DR1. And so perhaps you just are given certain treatments and you can easily address the DR problem that you have. DR2 is when it's referable and it's mild. And so that case, you need to be referred further. But the indicator here, it's mild. It's mild, and it's also the word they use is non-proliferative. And so it's not spreading as much. So it's still rather stable. That is classified as DR2. And then the appropriate treatment can be done with the appropriate level of urgency. DR3 is when it's severe and also very prolific in the sense it's spread quite a bit already. And so in that case, it's quite urgent. And so intervention may be needed quite urgently. And so these are all positives, but it's classified under DR1, 2, and 3. And so I thought, let me try train. Why don't we try train our model and see, rather than just identify all of them as positive, have the 3 separate positive tests. I had a link to that, but I think generally you get the point. So 1, 2, 3, you can actually distinguish them in terms of the features that are there. I do have a sample image. I just put this up last minute because I just want to show the various images. So this is from left to right. This is your normal image. This is DR1. This is DR2. And then this is DR3. DR3 is very easily, I find it's easy to identify because you can see the clots and the hemorrhages that are there. DR2 is what we looked at earlier. We can see some of those exudates, the fatty deposits. DR1 is a bit difficult to tell, I find, compared to the original, but that's what the model can help us find. So these are just for our own visual reference. And so after that, I just uploaded the images and each time I upload it, I tag them appropriately. So I have negative, I have my DR1, DR2, and DR3. And with that, with all my images uploaded and labeled, I then proceeded to train my model. With training, as I mentioned earlier, there's 2 ways. We can do a quick train, which, as they say, takes an hour, but it just took 10-15 minutes. Or you can take the advanced training, which by advanced, they mean you adjust your time. So you don't really adjust the parameters, you just adjust the time. And the point why this is important is because I'm using cloud resources, and if I train for 96 hours, I will be charged for using those resources for 96 hours. And so that's why it's just a way to optimize and see how much time do you really need. If you do a quick train and the results are not satisfactory, perhaps you can increase your training budget a bit reasonably to the point where it actually trains sufficiently. And this is just a budget. It may say 3 hours, but it may just take 40 minutes. And if it takes 40 minutes, you will not be charged for the remaining 2 hours, 20 minutes. It's up until you stop using the resource. So that's just if you want to take the advanced approach. I just use the quick train in my case. And what I want to show is the results for the first train. So when I trained using the image dataset I had, these are the results I got. With probability threshold of 75, meaning to say that a result of 75 is validated as a positive test. So I got a precision of 94, a recall of 66.7, and average precision of 97. What I want to, which is reasonable from the precision side of things. Recall, perhaps the reason why the recall is not that high is it has to do with the indicators below. So I cut off a bit, but you can see that I have certain warnings. So under the negative, my precision was 100, recall was 87.5, and this red bar here was what is telling me is that I don't have enough images. So they say you need at least 50, and I think we can understand why you need a high amount of images. Is just because of that repeatability. To have a representative sample, because you may have a high precision, but that's within the current data set that you use. And if you only use 37, there could be other images that you have not accounted for, and those may not be correctly identified just because your sample set was too small. And so that's the warning I get. This yellow line, hazard sign here was just telling me that my data is not balanced, in the sense that my negative is 37, my DR3 is 33, DR2 comes at 43. And so that again will have a certain bias, in the sense that certain labels have more data than others, and so it'll generally lead to that label having higher chance of positive test, because it's just there's simply more images on that one compared to the others. So ideally, you want a very balanced images between your negative and positive labels. What did I have on the next slide? Okay, so what I did, what I tried is I felt, okay, true, this is rather low. So I actually used another data set which had 1,000 images, and so around 1,000. So I trained that as well, just to compare. And you can see this is just one iteration, so it's not perfect. Your recall can be improved, but I just wanted to bring the point of I have more images. Again, it's not balanced, but you know, this is the reality of with data sets. And so the challenge with machine learning models, and in this case custom vision, is not so much the compute. The compute is now quite available. The problem is getting a data set that is representative. For example, as I'm a researcher and I have a colleague who's doing work in the mines, and so they're trying to employ machine learning models in being able to classify the size of the amount of particle size that they get when they use grinding machines up in the mines is called comminution. So when you grind minerals, what size do you get, and can you make predictions on how long the grind time is to the size you get? The thing is not they're struggling because they cannot find a ready-made data set on grind time and size. And so what they're doing is something they call transfer learning, where you're applying a model based from another field, so not just from this mining area or this particular grinding area. They apply it in another, they take it from another field and then tweak the parameters a bit and try to use it here to see if they can get a good prediction. So that's what it's another field that under subset of machine learning, which is something that is a reality. So ideally, as much as we want a balanced image, a balanced set, we may not have that. And so we have to work with the constraints we have. I wanted to demonstrate, so as this is more images, but you'll find that the earlier model actually did a better prediction. So see if I can switch to the actual custom vision API. I'll just share screen, it's easier. I have quite a bit open. I need to find, that's not it. That is not it. Okay, this is it. And so this is the custom vision project settings. This is DR demo 1. I want demo 2. So these are the two projects I made. And well, since I'm here already, you can see the other aspect of that is considered when getting a data. This is the one which have almost 1,000 images. If you compare the quality between the two, this is higher quality, and I actually can make better predictions with this than with this. So as much as I have more images, perhaps the more images to compensate for the fact that the image quality is not as high, and so the features are not easily visible. But let me find actual predictions that I made. Oh, you know what? I can just do a test. So I'm just going to test my model. This is the model 2. So this is, yes. No, this is the other one. So I do need the DR data set. So I'm going to pick, say, severe DR. So these are the images I used to train it, but I have a test data set within. And so this should result in severe DR, because it's under the severe DR category. And so if I put that in, that was correct. So that is severe DR. Let's try another one. Maybe I just had luck. I just picked the wrong image. So this is moderate DR. Moderate DR, actually, that's also correct. So that's 57.5 is compared to everything else, it's quite likely that it's moderate DR. So let's try. I thought this one was not so good, but turns out actually it's okay. What data set did I pick this from? Mild DR. Okay, well, turns out it's actually reasonable. The one last one. Let's try a healthy one. Let's pick an image. Oh, that's almost 100%. So, well, negative should be quite easy to identify. Well, it turns out the model actually works okay for those that we've trained it for. So, and the other one actually works fine as well. As much as I used fewer samples, it doesn't mean that it was not correct in identifying having a positive test. So let me just double check, since I think maybe when I go live things are different. But let me try this one as well. I might as well demonstrate. Just do a quick test. So browse local files. Let's see. This is the data set. I want to use the archive. Yep. Yes. So DR1 for this one. So test data. Let me see this one. DR1. So this has been, it's negative, which is incorrect because we got that from the DR1 data set. Let's try another one. So say DR2. But to be fair, DR1 is not easy to identify because as we noticed, it looks very much similar to the negative. Testing. And then select that. Choose DR2. Again, very hard to, this is definitely DR2. So we can see at this point, the model is not working very, very well. Just for completion's sake, do DR3. That one. Well, it says it's a DR2, which is really a DR3. Well, I guess that shows this is why. So with this one, the images are very little, and so it's not ideal to have this. So the data set is quite limited, and so it's better to have a larger data set, and ideally it's also good to have it as balanced. And so perhaps if you want to take this a step further and say record the amount of times you get DR1, DR2, DR3, you may find that one of the smallest amounts would be DR1, simply because your image balance is not the same. So that's a kind of a bias there that we try to avoid by being just having a balanced data set. So that's the demonstration on the computer vision side. I'll just switch back to my slides. Slides. Yep. So that was just a demonstration on the two models. I think it works out well because we can actually compare one with little data to one with a larger data set. And earlier on, actually, the other one, the demo one with the smaller data set worked fine than the other one. But well, in this case, we can see the one with the large data set works fine as well. Better actually than the other one. And so after that, I could have shown this. I'll just show it from this side as well. Just mindful of time. Once we are satisfied with the model, we'd use the prediction. You'd publish it, and then do we have a link to actually show how to hit the publish? Yeah. So there's a publish button there, and once you press that, you can publish it. You can then access your APIs, which will allow you to connect with the Powerapps service. So when you get to the Powerapps side, I'll show you what we actually need on this side. So that's the That's the custom vision side. Again, these are parameters which we'll need from the Powerapps side, which is the project ID in this case on this page. So we'll need that later. So we've seen how to build custom vision to upload files, to label them, and to create models and to evaluate them. You noticed for both evaluations, the model wasn't actually very the precision was good, but the recall wasn't as high. But for the one with the 1,000 images, we're able to get relatively a good prediction, and that perhaps you could train it further, but then it comes at the cost of how much do you want to optimize at the expense of compute time and cost, and as to whether does it meet the kind of level you want. So perhaps for us, it may actually be sufficient to have it at that level. However, if you want to improve it, there's always room to improve, add more images, refine your images if you have the ability to, and then train that further, or increase your training time. Perhaps that's the easiest variable to use, is just increase your training time. Maybe that will give you better recall, but I didn't get a chance to do that. So that's the custom vision side. I'll just quickly go through the Powerapps. So Powerapps is again part of our Office 365, and what it allows us to do is build apps with little to no code, and I think that's the great benefit of it. And it's not just being able to do that, but also being able to connect it with other services. And so you can have a functioning app that connects to a variety of services, which you can then have, say, on your phone, on your laptop, on your tablet. And that kind of accessibility has proven makes it a very high, an in-demand skill, and also a growing area for people to use for businesses, also in education as well. So it's being significantly being implemented just because of the ease and the amount of the little expertise when it comes to coding. So, but we do use logic though, just in a similar way to Excel, and so we'll look at that in a second. And so, we have the Power Platform, so Powerapps is part of the Power Platform, where we have is Power BI, Powerapps itself, Power Automate, and virtual agents. And the recent ones added recently, I remember, was the AI Builder, which allows you to do, for example, to analyze receipts, invoices, and just be able to do that automatically. And you can see how useful this is from a business perspective, or even for, yes, a general business is typically you'd need software developed for this, so that you can be able to have the right models, and then to classify receipts, and then be able to then evaluate your model, and then then you can actually have a good test the receipts, and then once all that's done, then you can actually use it. But a lot of that is already done with the Power Platform. So with the AI Builder, for example, I think all you do is just select, for example, if it's a receipt, you just select the appropriate one, and you just need to upload your data. And I think you can be able to see the metrics. Perhaps there's things you use to tweak it a bit, but a lot of it is already done for you. So that's just in general where Powerapps sits within the Microsoft Power Platform. So Powerapps are certain building, but this is within just generally with Powerapps. We will use the Powerapps Studio for our case. Perhaps best just to see this in the demo side. So I'll just quickly move through. So if you're building it, you have this landing page when you go to the Powerapps homepage. We're going to start with a blank model. So I'll just skip through this. Again, the demonstration of how the layout looks like. We'll see that later as well. Powerapps Mobile, yes, you can avail it either in mobile or tablet or even through the web as well. So I'll just go to the exercise. So we're gonna create our first app in Powerapps. So we have a layout, and then link it to the custom vision, and then do an app accuracy test. Perhaps at this point I should say, the custom vision model connector is actually in preview. So I think what happened is when this was first done, it linked fine, but I have had problems linking it. So I was not able to actually link it. So what I'll do, I'll just demonstrate how to do it, and then I'll show you a typical result of how it'll look like. So on Powerapps, on the landing page, we would just start with a blank app. So we would select the blank app here, and then we would just a blank canvas app, and we just click create. And so at this point is where I will switch to my actual one. And so from here, we will then connect it to custom vision. So let me just quickly switch. Once again, I'll share my screen just for you to ease. I need to find the Powerapps. No. Yes. So that's I'll start one from scratch. So I'll just start one from scratch so that you can just see a quick demo of how we're gonna go through it. So you create an app. I think I already have a demo 101. So I'll just make sure I don't duplicate. And so we're gonna use a phone layout. So I'm gonna hit create there. I'll do this manually. So we have a screen here, which is blank, and so there's always room to have design that you want. So, for example, if you want to change the color of this of the screen, it's just as simple. For example, in this case, because it's fill option, you can just change color. So if you want it black, you can type in black. But just because it's a simple one, I'm just gonna leave it at white. So what you want to do is actually link custom vision connected to our Powerapps. And so over here, there's various tools. Perhaps the more intuitive way is actually that's data table. I'll just use this. So here, when you hover this, it shows you data. And so when you click on that, you can now connect your Powerapps to a certain data service that you'd want. We want to connect it to custom service, custom vision. So under connectors, we have custom vision here. And so you can see it's a new one. So that's indicating it's in preview. Once you click on that, it connected. So at this point, I should have been asked to get my key, but it doesn't ask me to do that. And I do not know how to get it to ask me to do that. So I was not able to connect. But what I'll do, I'll just demonstrate how we built a layout. So on this screen, I'll just go back to the tree view. And let's say this would be the screen for uploading. So what you're going to do is actually upload an image. We're going to upload an image, and that uploaded image will then be sent to the custom vision model, and then tested, and then the results will then be reported on the Powerapps. And so we would see what is the recall, what is the precision on this side. So how we would do that, I would need a button. So to add a button, you just click on the button there. You can place it accordingly to where you'd want. Let's call this scan, because essentially this will be the button which we press. It will allow us to scan, to send the image to the custom vision service. I'm also going to add an image upload control component rather. So to do that, there's input. Actually, it's media. So under insert media, there's different things. There's camera. So part of this actually involved using a camera, because ideally, how you diagnose DR is by using a camera. It's called a fundoscope. And so the radiographer would have this camera within this device, and then they actually look at the retina of the eye. So this camera can be then you use this service, then connect it to your fundoscope for the professional, and then they can actually get the image, capture the image, and then send it to the model, and then get a result. But in this case, I'll just use add picture, because I'm just gonna get it locally. Add picture, and so this would be so this will allow us to upload a picture onto our app. And so what we need now to do is actually use a bit of logic, because when you press this button, we want to tell it to actually send this image to our custom vision service. And so with Powerapps, each component has various functionality. So scan is a button, and as a button, you can have design edits, but you can also have functionality as well. And so I'm looking for on select. Yes, I'm on select. On select, what that means is when you press select, what action do you want to happen? So when I press scan, at this point, false, meaning to say nothing's going to happen. But what I wanted to do is actually send this uploaded image to the custom vision service. And so to do that, there's certain variables that are within Powerapps. So first, how it would work with is the moment you upload a picture, you actually need to save it in a temporary database. So these are called collections in Powerapps. So to do that, there's the clear collect. And so the reason why it's called clear collect is that this collect would be the database. So in this one, I'd call it let's call it upload column. So that's gonna be the name of the temporary holding site for our image. So it's gonna be upload call. And so clear collect means every time you upload, it refreshes it. So that's the idea of clear collect. And so at this point, we need to actually call the custom vision service. And so to do that, I don't think I'll remember it off just on the top of my head. So I'll show it to you. Can I remember it? Custom vision dot classify. The classifying images. I feel like it was that one. But okay, you know what? I'm just gonna check on my own notes. Maybe I put it there. Yep. So it's custom vision classify image v2. Oh, I was on the right track. Image. Yep, v2. And so that's you need to call the custom vision service. And so what we need is the project ID. Now, project ID, I did show you earlier where we get this information. I'll just work with this one. So to get the project, this will be used for the connector, but to get the project ID, I'll just show you where it is. So this is the project. No, it's not that one. This is the project ID. So under settings in your custom vision side, you get the project ID from there. So you just copy that onto your Powerapps. And so we would put that there. Oh, I should put it there myself. Actually, you know what? It's easier to use the one I already have here, just for demonstration, for easier demonstration. So this is the same idea. So on the scan, just move that. Sorry, a bit too large. Yep. So when you scan on select, so what you have is gallery column. I called it upload column just to differentiate, but it's the same idea. So that's your collection where it will be stored. And then you call the custom vision API, and then you put the project ID. And then once you have the project ID, each time we train, we have an iteration. And so I only did one iteration, so I call that iteration 1. And then so this upload image 1 here is actually when we actually insert an image, it gets tagged with the name. And so because we have clear collect, we don't have an accumulation of images. Each time you upload an image, it clears the previous one and adds a new one. So that's what will always, in this case, it will always be upload image 1. But again, this is just for demonstration. So image 1, and then it gets sent for prediction. And so that gets sent through. And then I put this was the media, add image. This is the button. The other thing I added was a gallery. And so a gallery is used when you're trying to output data. And so once you add a gallery, there's various properties you can set. So originally it comes as a title, subtitle, and body. So for your data, what do you want to display? We just want to display the title and subtitle in our case. And so with that, what we did was change the title. So the title here earlier was tag ID. So I changed it from tag ID to tag name. And I changed it to tag name because we wanted to say what is the what is the name. So is it DR positive? Is it DR negative? So that is why tag name is useful in this case rather than tag ID. And so under subtitle, this is where it reports the score, the probability score. So for us to get that from custom vision, we actually have probability come in terms of decimal. So it's between 0 and 1. So it may output something like 0.75. We have to convert, ideally to be good to convert that into a percentage. And so there's this functionality in Powerapps, which is a round button, round formula. And so essentially you want to round this item. So the value which you get from custom vision, if we may work with 0.50, we multiply that by 100. So that gives us 50. But because it's likely more than having two decimal places, so maybe 0.5048 something. So we just want two decimal places. And so that's what, and we want to round that off. And then after that, we have an AND function, which is to concatenate and then add a percentage sign. So it's essentially just the number, add a percentage at the end. And so when we do that, we find that we have a display of 0%. 0 because we haven't run anything. And so when I press scan in this case, you would see, and so I have uploaded the picture. When I press scan, it should report the value here, the test and the value. But as I said earlier, for some reason, I can't connect my custom vision. So I will just show you how it is meant to look like. So if you in this was a simpler case, they just said negative and positive. But once you hit scan, and you uploaded the picture, once you hit scan, it then outputs the test, whether it's negative or positive, and then outputs the score. So in this case, it comes out as negative 63.49. So this is all done from, in this case, it's all done from your computer. You can do it from your phone. You don't have to access the custom vision endpoint directly. And so it's actually a very good ad if you can use Powerapps to do this. And especially if you think about, this is just uploading. You can also have the camera testing side, which if you connect it directly to a fundoscope, you can get the image sent through and scan directly to the custom vision model, just straight from Powerapps. And so that's the benefit of it. And so in this case, this was classified as negative. And that's how roughly how the Powerapps side works. I will just go back to the presentation to finish off. This, again, this was a landing page. So just to show you, this was a landing page for your app. So your clinic and design screens. So what I had, I'll use mine as an example. I'll just switch to this one. So I actually had a camera screen and I had an upload screen. So camera is when I use a camera, which I'm not using at this point. You know what? I'm pretty sure I connected it. It'll show you my room, but I think I just want to make sure it works. So that's the camera. 2 would be the source. It will not work because I am using my camera on Teams. But yes, you can connect your camera input there. And so you should be able to see a live image from your camera. But yes, so you can create screens, so you can make a fully fledged app if you want to. So that's the landing page. So the moment you open the app, the title is there, Diabetic Retinopathy Detector. If you want to do, this is just for background, they put I believe they would put a healthy eye. And then you can either opt for the camera test option or the upload image option. When you hit the upload image option, you go to the upload image screen, and then you upload your image and you get it gets tested. Camera test is the same, just with connects to your camera and you input the test. So that's how that side works. And so really, that is what I wanted to demonstrate in terms of using custom vision with a data set to create a model and evaluate that model, and then being able to link that to a Powerapps and be able to create the same model, test it from within Powerapps without even having to access the custom vision website. And so this can be very useful. Again, if you go back to the problem, rural areas may not have access to ophthalmologists or those facilities where they can get all these services. If you have a machine learning model accessible via Powerapps, so all you need to do is upload. So, well, yes, you still need to upload an image, but you can have a quick test and see, okay, this is a good chance. this is positive DR test, this is negative DR test. You can do that just from the data collected previously. And of course, that's why it's also important to have we've also seen how important it is to have a representative sample, so that you can have unbiased data and you can have, well, at least remove as much bias as possible and just have something representative and that can give you an accurate prediction. And as well, you can tweak your training time, you can tweak other parameters so you can have a accurate model that can be suitable for this kind of work. So that's it. I think I will skip the knowledge check just because of time. Well, I've just said the summary. I'll skip that as well. Next steps. That is, if you this was just touching this area. There's especially if you're interested in healthcare, there's a lot to look into. There's Microsoft LearnPaths, and there's also just exploring this yourself. You can improve the model. You can use other data sets. Kaggle has many data sets which you can use, especially that's the beauty of health in the health industry. Like data is not as hard to find as in other areas because a lot of the work is done by imaging. And so imaging makes it quite easily available. And so there's areas to explore, and I'll leave that to you if you'd want to have a look. So yep, so a bit more areas to explore within Powerapps as well. And so yeah, these are things you can look at. And of course, a disclaimer, whenever you do this and you're done with using your resources, just make sure you delete them, because if you're not planning to use them again, because they over time, and especially if you have a limit, I mean, you often have limited budget, you just want to be resource wise and cost wise. So if once you're done with the resources, just make sure you delete them as well. So that is it. Thank you for attending, and I wonder if you have any questions.